When we do the clustering, we can use the clustering as the pre-processing tool, as I mentioned to you before. What does it mean by pre-processing? So when you do the pre-processing, you need to check the data distribution. You need to check whether the data contains missing values. You need to check whether the data contains noise. You need to check whether the data contains outliers. So we want to make the summarize. So we want to make the summary of the data. We call it summarization. So some summarization, we call it like the, we can make the regression. So if we have the regression line, then we can have some idea about our data, whether they have the linearity or not. Or we can use PCA. So if you know the data reduction, PCA can be used for the data reduction, but not only for data reduction. We can use it also for showing the data summary. And other things like classification and association analysis. Compression. We can use clustering to compress the data. So let's say if you have picture, maybe you want to analyze the picture, but the picture is very huge on the size. So you want to reduce the picture size, so we can use clustering. So in here we got the image processing with factor quantization. So if you want to use the factor quantization, let's say you want to reduce the color, like this one, or you want to reduce, we call it the PC reduce, or we use the principal component reduce, and we can have like this result. And those kind of things, we can deal with the clustering. We can use the KNN, finding the K nearest neighbors. So localizing such to one or a small number of clusters. So when I explain to you about the K nearest neighbors in the example in the Python, so we have something like this one. If K equals to 3, then we want to check whether the surrounding objects, if we have at least three objects, then we can classify the object as the most detected object. Let's say I want to know what is this object, whether it is the triangle or star. So if we look at the K equals to 3, the nearest neighbor equals to 3, then because the dominant is the triangle, then I can say that this object is triangle. That's why the K usually we have letter, we have the odd number. The odd number means 3, 5, 7, 9, and so on. We will not use even number because there might be some equal number. That's why we need to use the odd number for the KNN. Or we can have the outlier detection. So if it is far away from any cluster, then it is the outlier. When we have the clustering, we need to measure the quality. What is the quality? A good clustering will produce high quality clusters. High quality clusters. What is the meaning by high quality clusters? It means we have the high intra-class similarity. Intra-class similarity. Low inter-class similarity. The meaning by intra means if I have one object, one cluster like this one, and if I have another cluster like this one, then the object inside this one, we call it, this is the intra. And if you want to see the difference between the red and the blue, so we call this is the inter. So interclass, it means the difference between different clusters. But intra-class means the objects inside the cluster. The intra means the objects inside the cluster. Okay. Now you can see the word cohesive. Cohesive between, cohesive within clusters. It means how they are related in the cluster. But if it is low interclassimility, it is distinctive between clusters. So they have different. Between red and blue, they are different. So the quality of the clustering, it depends on the similarity method used by the method. You still remember what are the similarity methods that you have before? Similarity measures. We use Minkowski. There are three. When the h equal to 1, what is it? It is Manhattan. When h equal to 2, it is the Euclidean. And when h equal to infinite, we call it as supreme. Okay. This is the basic distance measures. But later on, when you go to orange, there will be many other different measures. We can have like Jakarta, similarly. As you learn in the materials, you know about the cosine similarity. Later you will learn, maybe not learn, but you will check on the orange. We have the Mahalanobis similarities, Nobis similarity, and so on. Okay, so we will check later. So the different similarity method will affect the result. And how you can implement, and how you can discover some or all of the hidden patterns. So I give these figures. If the intra-class variability is low and the inter-class variability is high, I think they use the different word there and so, not this one. I think, yeah, they have the different word. So let's just use this one, high. High interclass similarity means, yeah, this one, they are in the same group. Low, it means, yeah, they are distinctive. So they have the high distance. But if you see this one, the interclass variability, yeah, they call it low, but maybe in this case I call it high. If the interclass variability is high, then it is mixed. So it is difficult to make the clusters. So if the intra-class variability in this case is high, so in this case is I can say is low. The intra-class variability is low, so I cannot see the relation between the objects. And the inter-class variability is low. So this one is there, yeah, this is low. Then actually, yeah, we can see those are two groups, but it's diverse. If the interclass variability is high and the intraclass variability is low, then it is difficult to find the good clusters. The dissimilarity of the similarity matrix. We have the similarity is the distance function. Okay, that thing you already know. The dij means the distance. So the distance function, as you might know, it is in the numbers. It can be used for the interval scale, but there are also some other similarity measure for Boolean. You know Boolean? True, false. Okay, 0, 1. Or there also some distance function for categorical. What you learned until now is the distance measure for numbers. We can also use some distance function for categorical, but I didn't explain what a distance measure for categorical. Ordinal. You still remember ordinal? Okay. We have the order. Okay. So if it is ordinal ratio, then maybe we have like 0 0.1, 0 0.3, 0 0.5. So it is in the order. The smallest maybe indicates something low, the highest indicates something high. Or we can also have distance function if it is related to factor. So they are different and they give you different results, which should be associated with different variables based on the application and the data semantics. So the quality of clustering is usually separate quality function that measure the goodness of the clusters. So we will learn maybe not too many quality functions. At the end, we can say that it is hard to define similar enough or good enough. So it's difficult. When you practice later, okay, it is highly subjective. So based on your analysis, based on your visual. So there are some clustering analysis. Okay, I would like to explain the concept first. Partitioning criteria. So the partitioning criteria means we can partition. This is the meaning by the partition. So we have box like this one, and then we can partition into two. Okay, we can make partition, and then this is also we can make another partition. We can partition the data into single level, or we can partition in the hierarchical. So this is the hierarchy. So this data and this data we can merge into one. This data and this data we can merge into one, and then this data and this and this, it can be merged into this one, and so on. So we can make the hierarchy. The separation of clusters. Whether the separation is exclusive means one customer belong to only one region. So this is an example, exclusive. So this objects, it is in this cluster. This object is in this cluster. This object is in this cluster. Okay. So it is well separated. We call it exclusive. Or it is non-exclusive. So one document may belong to more than one class. So this is the example of non-exclusive. So the black color, the red color, yeah, it is overlap. If we make the circle like this one, yeah, some of them are overlap. If you look at the news, okay, so the news, yeah, I think today we heard about the missile from the North Korea. So the news about missile, it can be related to the politics, it can be related to the international issues, it can be related to the security. So one news, it can be related to many topics of the document. We can say it is belong to more than one class. So the clustering also depend on the similarity measures. If it is distance based, you already know the Euclidean, or we use the factor. In the factor base, you learn about the cosine similarity. Or if we are using the road network, using the distance with the road, it is different with the connectivity. The connectivity means we can use the density or the contiguity. Clustering space. So we can use the full space with the low dimensional or the subspace with the high dimensional clustering. I will not explain more about this space. And there are some requirements and the challenges. Scalability. Clustering all the data instead of only on samples. So you learn in your assignment, if we have many data, let's say we have 1 million data, yeah, it will be difficult to understand all the data, and maybe the computer is not working well with big data. So you need to reduce with samples. But the issue is we want to use all the data. We do not want to use only samples. Then how we can apply the algorithm? Some of the algorithms are applicable only to the numerical. But our data is not only numerical. Your data can be binary, your data can be categorical, your data can be ordinal, your data can be linked. So link means like if you have the Facebook data or you have the Twitter data. So one people can be linked to another people. So if your data is mixture of this one, yeah, it is difficult to make the clustering. So like this one, this and this cannot link. This and this must be linked. So we call this is the constraint-based clustering. So some of those user may give inputs on constraint. Maybe if we are dealing with this kind of network, so when you go to Europe, you cannot pass by the Ukraine. So that's a kind of, you cannot link on the airplane zone, but you must link to another airplane zone. Use domain knowledge to determine the input parameters. So this is belong to the constraint-based clustering. how to interpret and how to use the cluster results. So this is also another challenge. And the other challenges is how to discover a cluster with the arbitrary shape. This is arbitrary shape clusters. Maybe it's easy to understand if the cluster is just circle like this one, two circles. But what is the meaning by this cluster? It is difficult to explain, but it may happen. And how we deal with the noisy data. How to do the incremental clustering and insensitivity to input order. And how to do the clustering with high dimensionality. High dimensionality means many attributes. So those are the challenges. So I would like just to mention some of the approaches. The first is partitioning approach. Construct various partitions and then evaluate them by some criteria. So for example, minimizing the sum of square errors. So we will learn this one. K means K matrix, errors, and etc. So if we have the data points, then we can do the partition. Do the partition means we can just see, okay, this one is in the one group. This is the partition. This is the partition. This is the partition. Or we can have another approach. We call it hierarchical approach. So create a hierarchical decomposition of a set of data using some criteria. So later we will learn about the agglomerative or the diffusive. Density-based approach. It is based on the connectivity and the density functions. So if we have our data like this one, we call this data is like moon. Moon like data. If the data is like moon, something like this one, we need to use the density-based approach. If we use the k-means, yeah, the result something like this. But if we use the density-based, we will get the result of the cluster like this one. Grid-based approach. Okay, there's another way to do the clustering based on the multi-level granularity structure. Model-based. Model-based means I have a model, okay, and then I want to use it for the clustering. So a model is hypothesis for each of the cluster, and then try to find the best fit of that model to each other. So I have this data, for example, and then I will just assume that this is the model. So I will move the circle and then check how many data are in the circle. So if the data in the circle is the highest, then we choose this cluster. So we call this is model based. There are some methods like EM, SOM, and so on. Frequent pattern. It is based on the frequent pattern analysis. I think you already know in the association rule. In the association rule, we have the frequent item set. So the basic idea is almost similar with this frequent pattern base. User guided or constraint based. So I already explained to you. We can make some constraint, whether they can link, they cannot link. So we can make it, it is user specified or it is application specific constraint. Link based clustering. So objects are often linked together in various ways. Usually we use it in the graph. So if in this graph we can see the relationship. The node 1, node 2, node 3, node 4 is connected. Then we can have the connectivity, and we will make like S, for example, this one is the sim rank scores. So we can make the scores about the connectivity of each of the node. Okay, just simple learning check. Cluster analysis is to find similarities between data according to the characteristics found in the data and grouping similar data objects into clusters. True or false? Find similarities between data according to the characteristics found in the data and grouping similar data objects into clusters. True or false? It is true. What is a good clustering? A good clustering is high intra clusters and low inter cluster. Okay. So we want to make sure the cohesive means it is in the cohesive within objects, and the low intercluster means the distinctive between objects. Okay. What are the considerations for the cluster analysis? So there are some considerations for the cluster analysis. You can see whether it is related to the partition. You can see the related to the distance, okay? Whether it is in the partitioning, in the distance, okay? And then the exclusivity. Mention the two of the major clustering approaches. So you have many. Okay? So the two that we will learn is the partition and hierarchical. Okay, so this approach we will learn in this PowerPoint. Okay, so we are going to learn partitioning methods and the hierarchical methods. The basic idea of the partitioning methods, we want to partition a database D of n objects into a set of k clusters. Okay. So we have D. D is the database. We have n. N is the number of objects. It means the number of data, the number of rows. And then K. K means K clusters. So how many groups that I want to create? How many clusters that I want to create? So yeah, this is the cluster. We want to measure the distance, sum of square distance, so it will be minimized. P minus Ci. So Ci is the centroid or the matrix of the cluster Ci. We will do the square and then we will do the summation and we will again do the summation until the k, so it will be the error. So we will check this one. Given k, find a partition of k cluster that optimizes the chosen partition. So we have the global optimal. The global optimal means we need to enumerate all partitions. So we need to check every partition and then we can measure. So we will use the heuristic methods instead of the global optimal. The heuristic methods, we can use k-means or the k-matrix. K-means, it has been developed by McQueen in 1967. So it's very old method. Actually, there's also another method. Okay? It was in the 57, but they have very basic one. And there's also another development of the k-means. We call it the k-matrix, or later we'll learn about partition around matrix. It has been developed in 87. So its cluster is represented by one of the objects in the clusters. So let's see. This is the step of the k-means. If you look at this figure, okay, you can see the k-means iteration 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So when the iteration 1, he will calculate what is the best centroid or what is the best center. And it will go to the next iteration until they find the best center. What is the best center? It is the best center means when we can see the mean point or the least error. Let's see it with example. I think it's better with example. Now I have the data x1 and x2. 1, this is the object 1, it is 0.7 and 0.0. 0.7 and 0.0. The data object 2 is 1 and 0.4. 1 and 0.4. The data object 3 is 0 and 0.7. 0 and 0.7. Okay. So we have 5 data. Now, how can we make the clusters? The first is we need to determine how many k do we want to create. So let's say I want to make 2 different groups. I want to make 2 clusters. And we have the data equals to 5. Okay, we have 1, 2, 3, 4, 5. So first, in the iteration 1, I can select any of the group. Let's say I choose this group. Okay, I choose the first is the 3 and 5, it is in the same group. And then I choose 1 and 2 and 4, it is in the same group. So this is chosen by random. For the iteration 1, we can calculate the centroid. What is the centroid? The centroid means the center point. So how we can get the center point? We know the number. Then the centroid 1, let's say this is 1, it is in the object 1 and 2 and 4. So we can see that this is the center. How we can get this center? We need to make the average of the x1 for the data object 1, 2, and 4. 1 is 0.7 plus 1 plus 0.3. Okay. 0.7 plus 1 plus 0.3 divided by 3. And the result is 2/3. And what about the x2? Here we have the 0 plus 0.4 plus 0.6. 0 plus 0.4 plus 0.6 divided by 3. So we get the center point. So this is the center point. What about the centroid 2? We have the data 3 and 5. So we have 3 is 0 and 0.4. So 0 and 0.4 divided by 2 because we have only 2 objects. And then the x2 is 0.7 and 1. 0.7 and 1 divided by 2 because we have only 2 objects. So this is the center point. Okay. After we have the center point, what we need to do is to measure the distance. We need to apply the distance, or we need to find the error. This error means I want to check the distance for every object to the centroid in the respective clusters. So I can have the 0.7 minus 2/3. 2/3 is the center. 1.0 minus 2/3. 2/3 is the center. 0.3 minus 2/3. 2/3 is the center for the x1. And then for every of this one, it will be square, square, and square based on this formula. This is for the x1. What about the x2? The same. We have 0 minus 1/3. 1/3 is the center. 0.4 minus 1/3. 1/3 is the center. 0.6 minus 1/3. 1/3 is the center. So we square of them. And we will get the result. This one, 0.4268. Oh, why the color is here? Okay, anyway. This is the result from 1 and 2 and 4. What about this one? The same. Here we have the x1 0 minus 0.2 square, 0.4 minus 0.2 square, and we have the second or the second additive which is x2, 0.7 minus 0.85 square, 1 minus 0.85 square. Then we can get this error, or this is the distance. I can say that the iteration 1 for this problem give you the error as 0.5518. Okay, so this is the error. Okay. Now, after I have the first iteration, I need to check another option. What is the other option? I need to go to the iteration number 2. In the iteration number 2, now I select different groups. Okay. When I select the 1 and 2 like this, and then I select 3 and 4 and 5 into the same group, so I can again calculate the centroid. What is the centroid? The centroid from 1 and 2 is 1 and 2, 0.7 plus 1 divided by 2, plus 0.4 divided by 2. Then this is the centroid. This is the centroid. The centroid 2 is from the 3 and 4 and 5. So we calculate divided by 2. Sorry, this one 3. Sorry, I missed this one. But I guess the result is same. Yeah, 0.23, 0.76. Yeah, here. 0.23, 0.76. Okay. So this is the centroid. Again, you can measure the distance. So the distance from this is 0.7 minus 0.85 square, 1 minus 0.85 square, and so on. So we will get the error or the distance from the centroid 1, and we can do the same with the 3 and 4 and 5, and we can get this error. So we can do the summation. This is here 3, 4, 6, 5. Based on your result, the iteration 1 and iteration 2. Since the value of this iteration produced 0.3465. What about the previous iteration? The previous iteration is 0.5518. So which one is lower? The iteration 2 is lower. So we can say that this option is better. So we can also say that we can choose this option for the clustering because it shows the least error. This is the smallest error. Of course, you can do again with the iteration 3, iteration 4, iteration 5, iteration 6, and so on until you find the smallest one. The smallest one will be chosen for the clustering result. So the k-means, because this is the k-means. K is any number, integer number, and means we want to find the centroid, or we want to find the average. They call it, this is division, because if you join the data structure, you will see the big O notation. The big O notation is the TKN. N is the number of objects, K is the number of clusters, and the T is the number of iterations. So we can just do for every iteration, for all the clusters and for the objects. So we have this big O, and yeah, it is somehow, if you learn in the big O notation, T and K, if it is constant, then you can just assume with the big O-N like this. Then yeah, it is somehow is still in the linear. If we look at later in the other algorithm like PAM or Clara, so it is power of 2. This also have power of 2, so it is higher. But yeah, it often terminates at the local optimum. And the other weakness is it is applicable only to objects in a continuous n-dimensional space. Continuous. So it is only for numerical attribute. If you have categorical data, k-means cannot do. So you need to use another like k-modes. and later we will check the K matrix. And the other weakness is we need to specify the K. So in the example, I mentioned K equals to 2. So it is one iteration. But are you sure the K equals to 2 is the best? We don't know. So we need to run again. If we want to check K equals to 3, so you need to calculate again. Okay. So some of the algorithm they propose to find the best K. The other weakness is it is sensitive to noisy data and outliers. So if your data contains noisy data or contains some outliers, then the result is not that good. And it is not suitable to discover cluster with non-convex shapes. The convex shape is something like this. So it's always in a circle. But non-convex, yeah, if it is maybe something like moon data, then it is not available with K-means. Okay. I think I will stop here. So I will continue on Tuesday. Okay. Any questions?